everyone. Welcome. My name is Bunn with Epic Games, and in this session, we're going to have a little bit of fun. We're going to be working with our new scriptable rigging system called Control Rig, and we're going to show you how it can be used to enhance your animations in UE4, as well as supplement your existing animation workflow. We got a lot of stuff to cover, so I'm going to quickly outline what we're going to be talking about here today. First and foremost, I'll give you the single slide overview of what Control Rig is and how you can use it to drive animation directly inside of UE4. From there, I'll show you how to enable the Control Rig plugin. Control Rig is available now in the early access state. We expect it to be production ready closer to 423, but I'll show you how to enable the Control Rig plugin so that you can start working with it. From there, we're going to jump into the meat of this session. That's working with Control Rig blueprints. This is where you set up your rigs in our blueprint visual scripting system. And then we'll jump into Control Rigs inside of animation blueprints. This is going to allow you to do things like procedural animations, retargeting, things that you could do at runtime with playable characters, which is what we've done with this wolf character from Fortnite. And I'll give you an example of that a little bit later. And then finally, I'll give you a sneak peek look at Control Rig sequences. What this allows you to do is basically keyframe animation inside of UE4. A little bit of a disclaimer, it's very, very early, but wanted to give you a sneak peek at what we're working on so that you can play with it and give us feedback and we can improve it down the road. Finally, I'll show you where you can get your hands on some additional documentation if you'd like to work with this feature on your own. So what is Control Rig? It is based on our blueprint visual scripting system. It's basically used to control properties in order to drive animation. It uses a much lighter weight virtual machine to translate your code than Blueprint. It's mostly to copy and execute your code. As you can see from this screenshot, it is a graph-based node interface that uses special rig units that manipulate bone transforms. Control Rig is primarily used for procedural animation as well as complex retargeting solutions. We do have a retargeting solution in place now, but that's only if your skeletal hierarchies are very, very similar. If you have more custom needs, Control Rig can help with that. We're going to show that a little bit later, as well as animating with Control Rig sequences. So that's my one slide overview on Control Rig. There's no better way to show it than to jump into the editor. So I'm going to go ahead and do that. And let's go ahead and jump over to the editor, and I'll just undock this. So this character on the left here is one of our characters from Fortnite. We're going to be doing some stuff with her today. On the right, we have our Unreal Engine. And the first thing that we're going to need to do is enable the plugin, which we can do by going to Edit and Plugins. And over here under the animation section, we have a Control Rig option. Now it's disabled by default. You'll need to enable it and then restart the editor. Just to save us some time, I've already enabled it and restarted the editor for us. Once you do that, you're going to get access to two new assets inside of the content browser under the animation section, one being the Control Rig blueprint and the other being the Control Rig sequence. Now we're going to be working with both of these here during this session. But first, we're going to work with a Control Rig blueprint. And we have a scenario that some of you may encounter when you're animating characters or working on your own project. So our character on the left, our Fortnite character, we have this animation of our character, and she's kind of throwing something, which looks pretty good. She's throwing a grenade or a frisbee or a paper or something. And this looks great. We like it. However, our design team, our artists, they come to us and they say, you know what? We want to add some more flair to this character. We want to allow them to be able to customize this character. Maybe they have a big shoulder piece, or maybe this character has something like this gauntlet piece here. And now you can see we have a problem with our animation. The claw is actually clipping into the fingers here. Now we have a dilemma. We could go back and animate the claw piece separately and have a whole slew of animations to match our character animations, but that's a whole lot of work that we don't want to do. So Control Rig can help by procedurally animating this claw based on the pose from our actual character. And that's what we're going to set up here today. So to do this, what we're going to do is we're going to right click and we're going to create a Control Rig blueprint. And when we do, it's going to ask us to pick a parent rig class. 99% of the time, you're going to be able to use the default Control Rig class. However, if you have some custom things that you need to do, you can create one in C++. It'll be available for you here. But we're going to use the default one, and I'm just going to click Create. And I'm going to call this the rig_gauntlet, like so. And I'll drag and drop it, move it into my gauntlet folder just to keep it nice and tidy. Perfect. So now what we can do is double click and open this up. And now we have the Control Rig editor. So if any of you have worked with animation in UE4, this may look very similar to an animation blueprint. There's a little bit of things that are different, but kind of recapping really quickly what we have a viewport where we'll see our skeletal mesh that we're going to be working with. We have our graph where we're going to set up our scripted scenarios. We have the details panel for properties, etc. Compiler results, I'm going to close that because we don't need it. But the main difference between this and an animation blueprint is this section down here. We have a rig panel, which is going to show all of our nodes that we have in our graph here and allow us to quickly jump between them. Directly next to that, we have our hierarchy. This is the joint hierarchy that we're going to be manipulating through Control Rig. And we can add one by right-clicking and going to Import and selecting the mesh that we want to work with and its associated skeleton. So I'm going to choose the gauntlet here because that's what we're going to be working with. And you can see it populates it with all the bones in that gauntlet piece that we can start manipulating. Now we want to see it in our viewport too, so I'm going to come over here to Preview Scene and just add our mesh like so. It's super tiny. So I'm going to undock it, put it over here, and focus in on it. Perfect. So on the right, it's our piece that we're working with. On the left is our control rig. All right, so the first thing that we need to do is get a reference to this hierarchy so that we know where all the joint transforms are. We can start manipulating them with control rig. First thing we're going to do is right-click, and we're going to look for a rig reference or rig ref, and that is this node here if we select it. So this node contains all of this information. It knows where all these joints are at any given time. I'm going to give this a better name than the default name here. I'm just going to call this base hierarchy, like so. It's our base hierarchy. Perfect. Now, for testing purposes, we want to be able to manipulate the finger inside of control rig here and then procedurally animate the claw piece based on the position of the finger. So the first thing we need to do is give us the ability to manipulate the finger. And we can do that by adding an apply FK or forward kinematic node. And you can see we can specify the joint that we want to manipulate. We can specify the transform that we want. There's some additional options here as well, but the first thing that we need to do is plug in our reference to our hierarchy. It's color-coded, so the nodes will match up. So we got to take our hierarchy reference and just plug that in like so. Next thing we need to do is specify the joint that we're going to be manipulating. In this case, it's going to be this top piece up here. So it's going to be the whole finger we're moving with this node here. So I'm going to copy this by right-clicking it, like so. And we'll paste that in. Perfect. All right, so now we need to supply the transform in which we want to move this joint. Now we're going to need two things. We're going to need to know where we started and where we currently are in order to do that. So we can right-click and we can say get joint transform. And we can plug in the joint that we're looking for, which is that joint there. We're going to need to know the current position. And we're also going to need to plug in our hierarchy reference so we know which joint we're talking about. I'm going to copy this and paste it. And we're also going to need to know the initial local position of this, so the bind pose. We can plug that in like so. Now you can see it spits out two transforms here, and we can manipulate those transforms by using a control node. The control node takes in a base, or our current. It also takes in an initial transform. So we can plug that in like so. Now you can see it spits out one transform. Now we could plug this directly in, but we're going to get some issues here because we need to be able to manipulate the finger relative to its current position. So what we need here is a get relative transform, taking in the result from wherever we move it based on the current. So let's plug that in. Now we get that final output and we can plug that in like so. And the last thing I'll do is just rename this so it's a little bit more descriptive. We'll call this the finger control, like so. So now if we compile and we go back to our control node and I come over here, I can move the finger up and down in the viewport like so. And as we do this, the claw piece is what we're going to set up next to move based on the finger's position. Now there's one other thing that we're going to do. We do this as a bit of a housekeeping, kind of let you test things out inside the editor. If I select this node here over in the details panel, all the way down at the bottom, there's a property called execution type. Where is this node being executed? Is it always being executed? Or if I click this drop down, is it only being executed in editing time? So inside of control rig only, because we want the animation to drive the finger. We don't want this apply FK to actually manipulate the finger. Only in editing time we want that. So it's purely for testing purposes. So I'm going to change that over and we should be good to go. So now we can set up the claw piece to move based on the finger's position. And essentially what we want is this top piece of the claw to move based on where we move that finger. So to do that, what we can do is copy this apply FK. change the joint that we're manipulating, which is going to be this one here. And in this case, we're making it additive. We're adding to it. We'll take our hierarchy reference and plug that in. And all we're really worried about is the rotation. We don't care about the translation of the claw or the scale. All we're really wanting to do is rotate it. So what we'll need is a couple of things. Similar to before, we'll need to know where we started and where we are currently. So we'll copy both of those, paste those down here. And for this, these are both going to need to be local. So we'll set it current local and initial local. Plugging in our hierarchy. So. And we'll expand the pins here so that we get just the rotation. Now we're going to need to do a little bit of vector math to get this to work. I'll try to get through it as quickly as possible. Essentially what we need to do is for the initial local here, we need to get the inverse of this and multiply it by its current position to give us the delta. So we could say multiply by its current to give us the delta. Once we have that, we can use a get angle around a given axis. And what this allows us to do is if we expand the axis here, we can get the angle around the X, Y, and Z axis. And if we look at our claw, down in the lower left here, it might be a little bit hard to see, we have our X, Y, and Z coordinates. Z is up in blue. So we actually just want the Z axis so we can swing it up and down. That's all we're really worried about. So we can zero out the X, and we can make the Z 1, because Z is 1 is up, like so. Now that we have the angle, from that axis and angle, we can get our rotation and plug that in like so. So with all of that, if we compile and we go to our finger control, now when we move the finger, the claw automatically moves along with it. Now the finger's kind of clipping into the claw just a little bit. To kind of fine tune it, we can add an offset to this, but a quick shortcut that I'll do is to take the joint below the one that we're actually manipulating and use that as my initial local. And that'll pop the claw up off the fingers a little bit better. So now when we manipulate it, it looks a little bit better. So this is one part. We're moving the top part of the hinge. We can take it a step further and have the digit of the finger actually manipulate the top part of the claw here. Fortunately for us, the script is going to be pretty much the same. We just need to change which joints we're manipulating. So I could copy all of this data here, just daisy chain it off the end, plugging in our hierarchy reference again. So, and we have one more we need to plug in there. And defining the joints that we're manipulating. So it's actually going to be this joint that we're manipulating now instead of that joint. So I'm going to copy this joint, paste this in. So, and to give us that offset again, I'm going to take the joint below, just like we did before. So we'll do joint 2 as the offset. And instead of claw 1, we're now manipulating claw 2. So this part of the claw versus that part. So if we compile, before we do that, just housekeeping, I'll make this the digit control. Perfect. So if we compile now and we select the digit control, now we can move the actual individual finger to get that part to move. This is all great. Now, there are some edge cases with this. For you animators out there, you're probably like, what about this? When I go like this, we're going to have some problems. So if I were doing this for real, I'd probably take into consideration what the other fingers are doing. But for the sake of this demo, I think this will be just fine for now, for the animations that we have. I think this will work. The last thing I need to do is make sure that on this digit control that we are setting this to only occur in editing time, because the animation is going to drive this. So our setup is done. What can we actually do with this now? If we go back to the editor and we go down to the content browser, we can create an animation blueprint out of this gauntlet by right-clicking and going to animation blueprint. We can double-click and open it up. This is the final pose that our skeletal mesh will enter. What we can do is use a copy pose from mesh node. And what this does is over in the details panel here, if I enable this checkbox, use attached parent, it's going to get the source from whatever we attach this to. So the pose data is going to come from whatever we're attached to. In this case, our character. So I'm going to click this checkbox to enable that. Last thing that we need to do is add a control rig node, which is new to animation blueprints. And you can see it just takes in a source pose and spits one out. So if you've worked with animation blueprints, you can do things like blends, you can do layered blends, you can do additives, all working with control rig as well. But for our demo, all we're going to do is plug in the output from our copy pose from Mesh, plug in the output to the final, and making sure that we assign our rig gauntlet, like so. And when we compile, it should be good. Now, the last thing that we need to do so that we can test this inside of the editor, we're going to go back to our Skeletal Mesh. And over in the details panel, all the way down here under Skeletal Mesh section, we're going to assign a post-process anim blueprint so that it can run in the editor here. And when I assign this, check out what happens to the claw here. It updates based on the position of the finger. Now, there are some artifacts from the glove texture appearing, which I'd probably want to mask out or not even include, but we have a much better result than what we had before. So now as the character is throwing that claw piece, opens up based on the position of the finger versus what we had before. And this is all being done procedurally, so I don't need to go in and hand animate any of this stuff. A lot better situation. If we take a look at another example here, here's an example of our character doing kind of an emote. You can see as she points, the claw is open. It's a little bit better versus what we had before. So one more time, here's our end result. Perfect. So she gives me the thumbs up. Sweet, so that's one example of using Control Rig for procedural animations. You could do this for like we did the claw, shoulder pieces, attachments, all that can be driven dynamically with Control Rig. Let's take a look at another example if I hop back to my PowerPoint here. So we did procedural animation, retargeting solutions. We are currently using Control Rig for one of our characters in Fortnite. We have this werewolf character here on the left here. And to give you some context, all of our characters in Fortnite, all of their animations were created with a normal humanoid biped in mind. So hips, knee, ankle, foot. Kind of like this baseball pitcher in the back. So we have the hips, the knee, the ankle, and the foot. However, with our werewolf, we have this additional joint between the knee and the foot. So we can't directly take all of our animations and pass those over to our werewolf character because the joint hierarchy is different. So that's where Control Rig comes in to help. We're using that to solve that for us and retarget those animations. To give you some context onto how Fortnite characters are created, we have this concept of a base skeleton. It's just an invisible skeleton that everyone shares. There's no skeletal meshes attached to it. And that base skeleton is what drives all of our animations. Because that base skeleton is shared across all the characters and it's the same, all characters can share animations, except for our werewolf character that's a little bit different. The character skins are layered on top of that. These are the individual skeletal mesh pieces. So the backpack, the body, the head. If any of you have played Fortnite, all the custom different pieces that can go on, get layered on top of the base skeleton. So how do we transfer the animation from our base skeleton over to the werewolf? So here you can see the green is the base skeleton playing this jog animation, and the werewolf with the gold skeleton, the upper body, the joints are the same. The lower body, the joints are different. So the lower body doesn't know what to do with that animation data. Now, we tried to do some things like IK to solve this problem, just a pure IK solution, but that gave us an effect that was undesired, kind of the dreaded puppet pulling effect as the IK targets, or the IK is trying to reach their intended target. So it's not ideal. And if we take a look at this example, a more pronounced run, kind of like a crouch run, it looks not how we want it, so it's kind of undesired. So how can we use Control Rig to do this? Similar to what we did with our gauntlet, at a high level on the bind pose, we figure out the delta transform between the bones in the human leg and the wolf leg. We then apply transformation on the incoming human leg to generate the animation. So at an even higher level, we're just basically defining the rule set in which to apply the rotation. That's what's going on in the blueprint here, and that's what we did in our gauntlet. So we're doing this for various joints along the skeleton to achieve the desired result. We then incorporate it into an animation blueprint, similar to what we did before, and we do still use IK to fix up some of the feet, but most of the retargeting is handled by Control Rig. It gives us a much better result. The best part about this is that all of this was done in Control Rig. There was no need for a programmer to help. I am not a programmer, so I would not have been able to do this without the help of Control Rig. You can see the full blueprint graph here from a super high level. That's all there is to it. And on the left, the more pronounced run animation with Control Rig and IK. Looks a lot better. So that's another example is for retargeting. I'm going to give you one more example. As I promised, it's going to be kind of a sneak peek at what's coming. One of our tech artists back at Epic created a full biped rig inside of Control Rig. Now, we hope to release this project as a sample project that you guys can kind of download and kind of pick apart. But as you can see, it's a little bit more complex than I wanted to get into in this session because I only had 30 minutes. But I'm going to give you a sneak peek and take you into the actual project so you can see it. So here we have the project on the right screen. I'm going to pull this over here and just maximize this. Here is the control rig graph for this setup. But essentially what it allows us to do is basically take this whole character inside of UE4 and move it around. We can select these joints here and kind of twist them. You can also select the arms and move these like so. I'm sure all you animators have done this before, plenty of times. And you can control this all the way down to the fingertip if you want. You have pull targets here as well, so we can fix that up like so. And there you go. This is great. What can we do with this? Well, with control rig sequences, we can now actually keyframe animations directly inside of UE4. So I'm going to show you an example of that. I'm going to hop back to the main editor here, and I'm going to right click and go under animation and choose a control rig sequence. I'll leave the default name and just double click to open it up. If you have not worked with it before, this is our sequencer editor. It's primarily used for cinematics, but it is a non-linear track-based system that allows you to keyframe various properties over a timeline. So we're using this to keyframe the joint transform and actually animate. So I'm going to dock this down here at the bottom, and we're going to plug our mesh into the level so that we can start working with it. So, and rotate it around. There we go. And over in the modes panel, we have our control rig set up. We need the actor that we're going to be working with. If I click this eyedropper, we can pick one from our scene. So we're going to pick this. Perfect. Now, if we go back to sequencer, there's a new track type called control rig, and we could specify our control rig blueprint. So I'm going to set that up. Now you see we have all those controls available directly inside of the editor here. And what this allows us to do is I can come down to sequencer here, and I can add tracks for all the various controls that we have. So for example, I can maybe do the left arm like so, and I can come up here and maybe do the right arm like so. And in the viewport now, I can take the left arm and just kind of move it up, kind of like I did before. Maybe rotate it around. Do something like this. We can add a keyframe. I'm going to kind of do the same thing with the other one. I'm not an animator by trade, so this may look very terrible, but I'll give it a shot. Perfect. So I'll add a keyframe for that, and we can scrub ahead a little bit in our timeline. And we can take both of these tracks now, and in the viewport, just kind of move both of those up and hit enter to add keyframes, and then maybe scrub ahead to frame 30, pull those down. I think you know where I'm going. If we move this ahead to get a little bit more. And just for good measure, I'll add one more set. And just copy these keyframes, copy and paste those. Take these, copy and paste those. And essentially what we've created is the ability to raise the roof a little bit. It's terrible, I know. But you can kind of see what's possible. We have the ability to keyframe animations directly inside of the editor. So if you have a situation where you need to fix something, no longer need to hop out, make those changes, export, import, you can do that right side of the editor now. So, recapping everything that we covered really quickly. If you want more information, pull out your smartphones, take a picture of this, go to our official documentation pages. It has all kinds of information on control rig so that you can start working with it. Recapping what we covered, overview of control rig. It's basically the ability to drive animation inside of UE4 either procedurally or a keyframe. You can also do retargeting solutions with it as well. Showed you how to enable the plugin. Again, it's available now. You just need to enable the plugin. We did some scripting inside of control rig blueprints and animated our gauntlet, and also incorporated it inside of an animation blueprint. So you can also blend between the control rig and various different blends. Showed you control rig sequences over on the right screen here, which was very terrible, but shows you what's possible down the road. And finally, again, refer to our official documentation pages. You can search our doc pages for control rig. It'll come right up. That's all the time I have. Thank you guys so much for sticking around. If you guys enjoyed it, thank you so much. If I have any questions, feel free to grab me on the side.